The energetics of a reaction is often represented by plotting the energy against the reaction coordinate, which is simply the progress of the reaction. On the left side are the reactants, and on the right side are the products. In this particular reaction, there are two transition states, which are represented by the two peaks, and one intermediate, which is represented by the valley between. Let's see how this works with an example. The reaction between ethene and HCl proceeds through the following mechanism. Each energetic peak along the reaction coordinate corresponds to a single collision, which we represent by the movement of electrons. In the first collision, the pi bonding electrons form a bond with the proton on HCl, and the HCl bond is broken. To represent this transition state, we show the forming and breaking bonds by dashed or dotted lines. Transition states, therefore, are snapshots of the movement of electrons at the peak of the energetic profile. After the proton is transferred, the product is a carbocation, which is considered an intermediate because it will exist until it collides with something else with which it will react. In the second step in this reaction, the chloride bonds to the carbocation, and the transition state is represented by the forming sigma bond. The overall change from reactants to products is the free energy of the reaction and is related to the equilibrium constant. The peaks, transition states, represent energetic barriers and are related to the rates of reactions. Reactions with higher peaks, more energetic transition states, react more slowly than those with lower peaks.